So, in this final section of chapter 3, we're going to talk about forced mechanical vibrations, which again, now we will take our differential equation, mx double prime plus cx prime plus kx, and we're going to set it equal to some function g of t, where g of t no longer equals 0. And again, if you want to go into that whole analysis of lambda and omega, we can manipulate to x double dot plus 2 lambda x prime plus omega squared x equal to, and then we use like capital G of t to denote that we have divided it by m. Again, you don't really need to know that, or if you don't care, it's fine. It's just one of those things where like computer, like if you're designing like MATLAB or something, like it's pretty nice to define everything this way so that you only have to change a couple of parameters, but again, it's all the same. So the big thing that you're gonna learn or see in this section that's different is this notion of transient solutions versus steady state solutions. So that's the big thing. The transient versus steady state solution. And I believe I may have misspoken in a previous lecture where I said steady states where it goes to 0. That's actually supposed to be transient. I hope I said the word transient, but hopefully, but it's okay. So transient versus steady state solution. So as t goes to infinity, so as you monitor long-term behavior, if your solution goes to 0, okay, and not just any solution, so I should take it back. So um, recall from 3.5 that the solution to non-homogeneous differential equations was y equal to yc plus yp. If t goes to infinity, um, sorry, not if, as t goes to infinity, if your transient, sorry, your complementary solution, xc, goes to 0, we say it's a transient solution. It could be any term, but as long as a term is going to 0, we say it's transient, okay? Um, xp, the particular solution, is the steady state solution, okay? So one important thing to remember is e to the negative infinity is 0 because that's going to happen a lot. And generally speaking, so this is what's going to happen is you're going to have a system, right? X of t and t. It's going to behave some kind of way, but then it eventually hits this point where it kind of stabilizes and then behaves like that. So we would say that, okay, let me fix that line. That this point from here to here, we say that's the transient spot, so the transient, and then from here to here, it's the steady state, right? And that's essentially what we're analyzing, like the transient behavior and then the steady state behavior. And so x will be equal to xc plus xp, which is equal to transient plus steady state, like that. And we know it should go to 0 because it's the homogeneous component, right? So, does this change the entire process of solving it? No. Just makes it more tedious because I have to find the particular solution now, but it doesn't make the problem any more challenging than before. just more tedious, honestly. So let's do our example. And we got to slide 100 with this example. So solve the IVP x double dot plus 2x prime plus 26x prime equal to 2 cosine 2t, sorry, 4t, not 2t. Given x of 0 is equal to 0, man, if they did not give you those initial conditions, this problem would be like 10 times worse. So solve the IVP and identify XC. So I'm going to use the what they use in the homework. So XSP, which is steady periodic, and X TR for transient. Okay. Steady periodic and transient. Yeah, so steady periodic, what did I say earlier? Steady state, same thing. Basically, they're asking you to just solve the problem. Okay, so it's very straightforward to solve for the, steady state. So step one is formula. X equal to XSP plus XTR, right? That's what we're solving for. Step two is we're going to find XTR. So we're going to do R squared plus 2R plus 26 equals 0. And we can't factor it, so then we're going to do the quadratic formula. So then R is equal to -2 plus or minus the square root 2 squared minus 4 times 1 times 26 all over 2 times 1. R will be equal to, and if you do the algebra, you're going to get -2 plus or minus the square root of 25. Sorry, -25 over 2. And so then R is equal to -1 plus or minus 5i. So we now know what alpha and beta are. So going over here, R is equal to -1 plus or minus 5i. That's alpha, that's beta. So then the transient solution is going to be equal to e to the -t C1 cosine 5t plus C2 sine 5t, like that. You can't solve for C1 and C2 yet because you need the particular solution to do that. But I have found my transient solution, right? Got the first part of the answer. Okay. Now, again, got to solve for A and B later. Sorry, C1 and C2 later, but that's the basic idea. Okay. Now, we'll go to the next slide and we'll do step 3, which is to pick an XP. So we're going to pick a particular solution. So we have cosine. So that means XP is going to be equal to A cosine 4t plus B sine 4 times t. And then step 4 is derivatives. So XP equals A cosine 4 times t plus B sine 4 times t. And then if we take the first derivative, we get negative 4a sine 4 times t plus 4b cosine 4 times t. Take the second derivative, negative 16a sine 4t. Nope, that should be cosine. And then minus 16b sine 4t, like that. So we have our derivatives. And then step 5 is plug in. So now we get to write out this massive equation, right? Hopefully we can fit it in one line this time. So negative 16a cosine 4t minus 16b sine 4 times t plus 2 times negative 4a sine 4t plus 4b cosine 4t and then plus 26. A cosine 4t plus b sine 4t. Nope, was not able to fit it all. Equal to, what would it be? 2 cosine 4t, right? Now, through the process of foiling and combining like terms, right? Notice, and I'm not going to show all of it just because it's going to take too much space here. Negative 16a cosine will combine with uh, this one right here, and then this one right here. So those are going to combine together. And then this is going to combine together with this. Don't forget that there's a 2 out there in 26. And that. And if you combine them together, what you're going to end up getting is 10a cosine 4t plus 8b cosine 4t, and then plus 10b sine 4t minus 8a sine of 4t equal to 2 cosine 4 times t. And then from there, I can factor out the cosine and sine, and I get 10a plus 8b cosine 4t plus 10b minus 8a sine of 4 times t equals 2 cosine 4t. And that is the equation that we have. So if you haven't seen it yet, there is a video where I solve systems, showing you how to do it on a Desmos calculator. So that way you can not have to do like elimination method and all that stuff. But we will solve it now. So plug in differential equation. Okay, so that was step 5. Step 6 is to group by terms. So we group by terms, and then step 7 is equations. So now we're going to set up our equations. So we're going to have one for sine of 4t, and then cosine of 4t. And let me just move these down. Let's actually copy this equation so we can see it and move it over. So reminder, left side has to be equal to the right side. And so for sine, right, plus 0 sine of 4t, we get, actually we should do cosine first, makes sense to do in that order. 10a plus 8b is equal to 2, and then 10b minus 8a is equal to 0. Just so you can see where the equations are coming from. There you go. Solve this using any method that you prefer, right? So for this one, let's do elimination method, just so we can have an example of it. So I'm going to line them up by A and B. I'm going to multiply the top and the bottom by a number that makes them equal and opposite for the letter I want to get rid of. So I'm going to do 8 here and 10 here, 8 here and 10 here. And I get 80A plus 64B equals 16. And I get negative 80A plus 100B equals 0. Make sure people know this is 0. And then I add them together. These cancel out. I'm left with 164b equals 16. B is equal to 16 divided by 164, which when simplified will be 5. Wait, does that make sense? No, 4 over 41, like that. Right? So we got B. And then for A, we pick equation and solve. So it doesn't matter which one. I'll just do 10 times 4 over 41 minus 8a equals 0. So I get 40 over 41 minus 8a equals 0. 40 over 41 equals 8a. So then a is equal to 40 over 41 times 8, because I divided it over. And then from there, we're going to get 5 over 41. And so there are the undetermined coefficients. And so xp is equal to, which one was a? 5? Yep. 5 over 41 cosine of 4 times t plus 4 over 41 sine of 4t. Make sure you put them with the correct sine and cosine. And so now we have our general solution. So step 8. So equations and solve for A and B. Step 8 is a general solution. So x equals xc plus xp, which is equal to, if we think back, we have c1. I forgot. C1 cosine 5t. All right, e to the negative t, c1 cosine 5t plus c2 sine 5t plus 5 over 41 cosine 4 times t plus 4 over 41 sine of 4t. So you can see that these answers get quite massive. And then step 9 is solve for C1 and C2. So note that this is XSP, right? The steady periodic. And then now we just solve our C1 and C2 so that we can find the transient, right? The one where we can do that. So solving for C1 and C2, we're going to use x of 0 equals 0, x prime of 0 equals 0. So if we plug in 0, we get 0 equals e to the 0, c1 cosine of 0 plus c2 sine of 0 plus 5 over 41 cosine of 0 plus 4 over 41 sine of 0. Gone, gone. So 0 is equal to c1 plus 5 over 41, which means c1 is equal to negative 5 over 41, just like that. Is that always going to be a pattern? No, it's just what happens in this problem. So we got that. And then from there, finding, this is going to be the most annoying part because I got to take the derivative of everything. So this is a pretty big derivative. So taking the derivative, so x prime of t is equal to, well, just got to do a bunch of chain rules. And, well, we got to do a product rule for the first one. And then the second part is the chain rule. So f prime g, well, I guess I should just write this all down over here. Let's just copy over this function. Okay. So then x prime is equal to product rule, f prime g. So negative e to the negative t times c1 cosine 5t plus c2 sine 5t plus e to the negative t times 5 negative c1 sine 5t plus, let's see, cosine, so 5, okay, yeah, c2 cosine 5t, all right, that's the product rule, plus 5 over 41 times 5, nope, that's the wrong number, 4, but negative because of it becoming sine, plus 4 over 41 times 4 cosine of 4t. This is one of those things where if the initial condition wasn't x of 0, the answer would be all of this. Like this would be a number. Like that's why you're very happy when it's like x of 0. Or if they use pi would be okay. If they did pi over 2, some of them would get rid of, but some of them would still be kind of nasty. But that wouldn't be too bad. But if they give you like x of 1 equals 1, the whole answer would just be a bunch of cosines and sine that add up into just a ugly number. So the fact that it's 0 is not because they want to make it easy for you. It's just so that they don't make it un just unmanageable with the number of values you have to carry around. So 0 is equal to e to the 0. You see this negative sign right here? That negative sign would be the detriment to so many students because it would be -1. So that negative sign there is actually super important. Uh, Cosine of 0 is 1. Sine of 0 is 0. I'm just going straight into like the, because I'm just not going to have enough room to write it all down. 1 times negative 5c1. Nope, but that's 0. Plus 5c2 plus, I guess minus, no, plus 0. Doesn't matter because it becomes sine. Plus 16 over 41 times 1. So then 0 is equal to -1 times C1 plus 5C2 plus 16 over 41. We know what C1 is. C1 was -5 over 41. So 0 equals -1 times negative 5 over 41 plus 5C2 plus 16 over 41. So then 0 is equal to 5 over 41 plus 16 over 41 plus 5c2, which then means we get 21 over 41. Well, can't forget the 0. And then we get -5c2 equals 21 over 41. And so then c2 is going to be equal to -21 over 205, if I did that correct multiplication. And that answer looks correct according to the solution. So there's our answer. So all in all, x of t is equal to e to the negative t, -5 over 41 cosine of 5t minus 5. That's incorrect. 16, I believe. 21, still wrong. I made that negative right there. Sine of 5t plus 5 over 41 plus 20, nope, 16, nope, 4. 4 over 41 of 4t. And that's the answer. This right here, that's x tr, and that right here is xsp. I just want to point one thing out. I think, so just to be clear, so I write this as steady state. I think steady periodic, at least looking at the homework, is equal to a cosine omega t minus phi. So you might have to convert it. From what I probably recall, Edfinity would accept the steady state version, and you wouldn't have to. It doesn't say specifically in the directions you have to, but I'm just letting you know that if one of the reasons it's saying it's wrong is because it's not in the steady periodic form. Again, they don't mention that you have to convert it, but in the solution they do convert it. So at the end of the day, steady periodic, steady state, it's the same thing. It's just maybe one is asking to be in a specific form. So just as a general awareness, potentially. But I mean, that's equal to steady state. So keep that in mind. But that's 3.8. Just being able to do problems like that, and that's just these very long problems of solving for particular solutions, and then at the very end having to do the coefficients, which is kind of annoying because you got to take massive derivatives. So if you can do one of these, like this is probably like a good difficulty of like exam style. Could be a little bit easier, but anything more than this is just time consuming, if anything. So that's 3.8 for you.